Welcome. This is Dr.Abirami from the Department of Artificial Intelligence and Data Science, SNS College of Engineering. This session we are going to discuss on threads in Java. A thread actually is a lightweight process which is not like a process itself, but it shares a memory with the process, thereby improving the performance of the CPU. These threads are used to keep user interfaces responsive, and it enables the parallel processing in many applications, especially in a web-based application. Java provides two ways of creating threads. One is using the thread class by itself, another one is using an interface called as a runnable interface. And we can use these two methods to create as well as to manage the thread functioning. Understanding the thread and the behavior of the thread is very essential in order to go with an effective Java programming. Let us see some benefits of multithreading. Multithreading increases responsiveness. It goes with the resource sharing, thereby making efficient use of the CPU as well as the memory. It goes with an improved performance by ensuring that there is a parallel execution of multi-processes running at the same time. We have modular design here where the complex programs can be divided into simpler forms using concurrent module methods, and this type of multi-threading concepts are mainly used with web servers to handle requests which are multiple times. Now we will see the state transition diagram, or otherwise called as the thread life cycle. How actually a thread starts with and how it processes during its execution stages, and how it stops or ends its process. Like a thread is a lightweight process, so it's not actually a process by itself. So a thread can be created. You can make a thread to run. A running thread can be made to stop, or you can make the running thread to wait for a period of time, or you can make the running thread to block for again a period of time, and can resume the process of a thread and making a thread to complete successfully. In order to go with these stages of a thread execution, we have defined here the thread life cycle, or otherwise called as the state transition diagram. Here, the first stage is going to be the new, where we are going to have a new thread being started or created, we call here. And the created thread now has to go to what is called as the running state. In order to move a thread to a running state, we have to use two means, what is called as a runnable or thread class, and using which we can start the thread. So we are here going to have a method called the start method, which gets with the thread to start running. And a running thread can now go to a yield state, where the transition is going to be from running to runnable, and after that it can even get back to a running state through the run method. So we have the run method here, which is here overridden method, that is method overriding is performed here in order to make a thread to run. When running, a thread can go to a blocked state either using the methods suspend, wait, or sleep. A wait and sleep can have a time being mentioned, where once the time elapses, the thread automatically initiates and moves from the blocked state to the runnable state and starts executing. You can even have a simple wait or a sleep without a time lapse, where automatically it gets resumed back using a notify or notify all method. Remember, if you are using a suspend method to make a running thread to a blocked state, We need to wake it up using the resume method. If a thread is now moved from a running state to a blocked state using a wait or sleep, then the method notify and notify all is used here to make a blocked thread to a runnable or running thread. When the thread is running and when it completes its execution, you can stop the thread by making a stop method. Actually, the stop method has been now deprecated and we don't have the stop method particularly used with the thread execution, but we can make a thread to stop once the program terminates. So that means the thread automatically stops once the program terminates. And when the thread stops, we call that particular state as a dead. That is, the thread is now being killed. Thank you.